the part 2 of the video under Hess law, we have a beautiful question. Given the thermochemical data below, find the change in enthalpy for the following reaction. Now, you can see that we have these two reactions, but this last reaction, the enthalpy, it doesn't have an enthalpy. So that means it's the one you're supposed to find. And that is, this is your base reaction. Is this reaction you should be working with. Remember the rules I said in the part 1 of the video. If you have not watched the part 1 of the video, endeavor to watch it. It's on our channel. If you don't have prior knowledge of this calculation without the part 1, it may give you a very kind of it may be very hectic for you. Now, remember these are base reactions, so we are not touching this. And then our aim is to make this first equation and second equation to look like this equation, this third equation. And so, of course, you know, like I said, if a reaction appeared in the first, or if there's a compound that appeared in the first or second, or an element that appeared in the first and second equation, that is not our problem. Now, coming to this place, look at this equation. From the first equation, look at it very well. We have water in the first equation. We have water in the first equation here. This first one, there is water here. Our base equation here, we have water. Now you can look at the mole. Here is 2 and here is 2. So we are good to go. So we are not touching anything here. Is it not? So I will just bring it out here. So you just write it out. We are not touching anything, no adjustment. And so we have 2HO2. Then you have 2H2 plus O2, right? Then you have your delta H to the plus 572. We are not touching it. Now, remember from the part 1 I said immediately you have take one. You have done with this first equation. Don't go and say, okay, hydrogen. Of course, we are not even touching hydrogen because hydrogen appeared here and here. Once you take one, you do one of the equation, that is the end. Don't look at anything again. Now, coming to the second equation, look at, we have hydrogen fluoride here. Look at it. The hydrogen fluoride is at the reactant, the HF is at the reactant side. But our base reaction here, the HF is at the product side. And so we want to make this equation to be at the product side, because this is our base. We want to make these two equations to look like this, exactly like this. And so since this is at the reactant side, but our base reaction is at the product side, so we have to change it, revise it. And so remember from the part 1, whenever we revise this reaction, the delta sign must change. Now look at it. In this place we have 2HF. We will revise it, but look at it. Here is 4HF. I said we have to make it to look exactly like this. And so first of all, we have to revise it. Yes. And after we revise it, we have to times it by 2. Is it not? So here is the revision. If you revise it, you have something like this. Let me come to this side. If you revise it, you will now have H2 plus F2 to now give you 2HF. Now, the next thing is we have to times it by 2. So you have H2, 2H2 plus 2F2 to give you 4 hydrogen fluoride. Now, can you see that this now look exactly like this? Now, the next thing we have to do is also multiply the delta H. Remember, whatever we multiply at the equation, we must multiply the delta. So, and if you multiply it, this is 547. And if you should multiply it, what are you going to get? What you will get is delta H will be minus. Remember, here is plus. When we revise the reaction, it has to change sign. So here should be 1084 minus 1084. Are you seeing it? So let me write this out. so that you not be confused. Here is 2H2O plus 2H2 plus O2. You have delta H572. Then you have this one 2H2 plus 2F2 plus 4 hydrogen fluoride. Then you have your delta H to be minus this 84. Now the next thing we are going to do is we have to plus this. But before we plus, we have to cancel out. Look at this thing very well. The hydrogen that is in the first equation and there's hydrogen in the second equation, and so they will cancel out. They will cancel out. So do we have anything in the first that is in the first equation that is not in the second equation? We don't. So the next thing is we have to add it up, right? We have to add it up. Now, remember, we want to make these two things to look exactly as our base reaction. Look at our base reaction. So we want to make it to look exactly like this. So the next thing is for you to plus. If I plus this, you start from here. Here you have 2H2O. This already has cancelled out. Are you seeing it? This has cancelled out. What am I doing? Here should be, let's dump the, here should be an arrow, not plus. This is the product. Here should be an arrow. So the next thing is we are done with this one. Then we have to plus this 2F2. Then, oh my God, what is wrong with me putting all this plus? Sorry about that, please. Then the next thing is there is an arrow. Then you write the product O2 plus HF plus 4HF. Now, can you see that this look exactly like this? Of course, it look exactly like this. Then the next thing is for you to know the delta H. Now, plus 572 plus minus 1084, and you should get an answer of minus 512, and that is your delta H. If you get used to this thing, you don't even need to use to write this thing. Immediately you times, divide, and get your delta H, because delta H is what we are interested in. So this is the smallest one, and we're going to continue doing the one that is kind of hectic. Of course, we are into this. You have given the thermochemical data, find the enthalpy for the following reaction. Look at it. We can see the three reactions have enthalpy, but these do not have enthalpy. So you have to calculate it. And what it means is this is your base reaction. You don't touch it. You only make sure that this equation 1, 2, and 3, you adjust it, you manipulate it to make sure it's exactly as this equation 4. Are you with me? Good. And of course, remember, when a quantity appears in more than one equation, we don't regard it. What am I saying? Look at nitrogen. Nitrogen is here, nitrogen is here. So, of course, we are not even interested in it at all. Look at oxygen is here, oxygen is here. We cannot consider it. It is on our part 2. The part 1 of the video explain all these things. You can see here, nitrogen is not a problem. Oxygen is not a problem because it appears more than one. Hydrogen is also not our problem. Now let's start from equation 1. Equation 1, we have ammonia here. We have ammonia here, so it's okay. But then the number of moles here, you can see here is 2 and here is 4. And so remember, we want to make this to look exactly as this. So of course you already know what we have to do. What we have to do is we have to multiply this first equation by 2 so that it can look exactly like this. And so this is solution. So if you multiply it by 2, you have 4, and then it will give you 2 nitrogen plus 6 hydrogen. Remember, whatever you do, you have to do in the delta H. So this will give you, the delta H here will give you, this is 180, 184, right? Good. Now we are back to the second one. Look at water here. And of course, water only appeared once, right? Now, but the water in this second, and remember, like I said, immediately you solve one. Like here, we only consider ammonia. You won't come back to this reaction to say you want to consider nitrogen or hydrogen. It's not possible. Once you consider one compound, the ammonia, you have to go to the second one. Are you seeing it? So only once. Every reaction you have to consider once here, except on special cases, which I'm also going to do the video here. So here we're already done with this place. Of course, we're not considering nitrogen and hydrogen because it appeared more than once. So the next thing is water. Water appeared alone. Now look at this thing. Water is at the reactant side. Water is at the product side here. So we have to revise the reaction. And remember, whenever we want to revise the reaction, we have to change the sign of delta H. So revising this reaction, and also note something, the moles of water is 2 here, the moles of water is 6 here. So for me to get the same moles of water, what am I going to do? I have to multiply this reaction by what? By 3. And then I have to revise it. I'm going to do it straight, direct. So if I revise it, that means this will not be the reactant and the reactant will not be the product. And at the same time, I'm going to multiply it by 3. So multiplying this thing by 3, that means here will now be 6H2 plus 3O2. Now, multiplying this by 3 and taking it to that other side, it will now be 6H2O. Remember, your delta H, the sign must change. So you have minus, and you have to times it by 3. So 573, if you times it by 3, what you will get is minus 1716. Remember, the sign must change. Why? Because the equation was reversed. Now, the next thing, we are done with this first and second equation. So, the third one here is, we're not considering, of course, we're not considering nitrogen, oxygen, we're not considering it because it appeared more than once. What we are considering here is the N2O, the NO, right? So, you can see that the NO here appeared only once. Now, in the reaction, the NO is also at the product side. And here is also at the product side. But we have a problem. The NO, the number of molecules attached to the NO, the nitrogen oxide, is 2. This one, we want to make it to look exactly like this. So we have to multiply everything in this reaction by 2. I put 3R. What it means is multiply by 3, revise it. So multiply this thing by 2. And of course, you have to leave it like this because they appeared both on the product side. So here will now be 2N2 plus 2O2. Then here will now give you 4N0, nitrogen oxide. And of course, your delta H, the sign will not change. It remains the same. So minus 360. Right? Good. Now, the next thing we have to do is we have to add all these. We have to add them together. Now, of course, you know, before adding, those that are repeated more than once will cancel out. Look at this place. Nitrogen, it will cancel out. And they are even the same. So nitrogen will cancel out. The next thing that will cancel out is hydrogen. Look at here. Hydrogen is plus 6. Here is plus 6, so it will cancel out. It will cancel out. What other quantity is going to cancel out there? Look at it very well. Which other one will cancel out? Hydrogen will cancel out because they have the same. That's all. Nothing is going to cancel out again. Then let's plus it together. Now here at this first equation, you have 4 ammonia, right? We don't have anything again. Here, this one will cancel out. This and this, so we don't have anything. So at the reactant side is only this place. Then here we have 3 oxygen and 2 oxygen. So plussing it together will give us 5 oxygen, O2. Then at the product side, there's nothing at the first equation. So plussing this, so you have 6H2O plus 4NO. Can you see that this look exactly like this? This was our base reaction. Can you see they look exactly like this? That means you got it. The next thing for you to do is for you to calculate your delta H. So plus this thing together exactly the way it is. on your calculator, and you will get equals to minus 1892, which is the answer. So can you see how this thing is being done? So the more you solve it, the more you get to understand what it's all about. It's not that hard. We are into another example. And so look at it. Calculate the delta H of the following reaction. Of course, if you see something like this, you know that you're going to use Hess law. Now, let's continue. Of course, you know that this is our base reaction. And of course, the first thing we are going to consider in this equation, can you see that we are not going to bother ourselves with this? Why? Do you know reason? Why? Because water appeared here and here, so it's not our business. And of course, you are not going to bother yourself with CO2. Why? Because it appeared here and here. So the next thing you should bother yourself is hydrogen here. Now look at hydrogen is at the product side, and here is at the product side. Remember, the aim is to make these three things to look exactly like this. And so the hydrogen is at the left-hand side, at the product side. And of course, that's where we want it to be. The next thing you consider is our base one here. We have only the moles of hydrogen is 1, while the moles of hydrogen here is 2. So we have to the coefficient actually. So the next thing is to make this the coefficient of hydrogen here to be 1. And how can we do it? We have to multiply this whole equation by half. 1/2. So multiplying it by 1/2, this is the solution. You know how you can pause the video and solve this, so easy. Multiplying it by 1/2, that means here will now be hydrogen, right? Then here will be, this is water, this is hydrogen, plus dividing this by 2. You divide it by 2, don't be confused. You divide it by 2, here will give us plus 1/2 O2. Of course, the delta H must also be divided by 2. And if you divide it by 2, you should get plus 286. Then the next thing is we will not consider O2 because there is O2 here and there is O2 here. So the next thing we consider is carbon. Now look at carbon is also, this question is even too easy. Carbon is also at the product side, and here is at the product side. But the coefficient of carbon here is 2, is 1 here. So all we need to do is multiply this whole equation by 2. Remember, our aim is to make these three equations to look exactly as the fourth equation. So multiplying everything by 2 is, so here you will now have 2 CO2 to give you 2 carbon plus 2 O2. Remember, you have to multiply this, the delta H, and multiplying it, what you get is plus 8788. The last one of the reaction is this. We will consider this. We will not consider O2. It appeared in 2 of the equation, so this is what we will consider. Now remember, here is 2, and then here the quotient is 1. Do you know what we are going to do? Of course, you know what we are going to do. We have to multiply everything, all this equation, by half. Multiplying it by half, you have something like this: C2H2. So here is plus 5/2 O2. Then it will give you 2 C2 plus water. And of course, you have to also divide this, and that should give you 1300 minus 1300. Of course, what we have to do is to plot everything, right? But then we have to cancel out first. Now look at what is happening here. Pay attention very well. Do you know what we're going to cancel out first? Of course, the CO will cancel out, right? The next set of things that will cancel out is your oxygen. Your oxygen will cancel out. Now we have 1/2 here. Look at this thing. 5 divided by 2 is 2.5. Is it not? Here is half plus 2 is 2.5. So both this oxygen will cancel out. Are you seeing it? So we are left with just this. We are left with just that, right? So the next thing is for we to start solving. Okay, water will also cancel out. Water will also cancel out. So the next thing is just for you to write this whole thing and it's over. So here is, we have only this, C2, H2, and of course water have cancelled. Then we go to the product. You have, at the product here, we have hydrogen 2 plus 2 carbon. That's all. All of this has cancelled. Then, of course, the delta H plus everything exactly the way it is, and you'll be left with an answer of minus 226. Minus 226. So that is, what is it? Like I said, this is so easy. It's so easy. We have an assignment here. Please calculate the delta H of this value. Kindly drop your answer at the comment section. Please solve it and drop your answer at the comment section. Thank you very much.